Alright, so let's remember what this last example was. We were looking at a committee of 10 people on a committee, and we were looking for a 5-person subcommittee. And there's going to be one chair person and one secretary. So how could I solve this? Well, I can think of two ways to figure out, you know, how many ways can we do this? Well, there are really two operations going on. One of them is choosing the 5 people on the subcommittee, and the other one is choosing the chair and the secretary. But they could happen in two different orders. Either we could choose the subcommittee and then from those people choose the chair and the secretary, or we could choose the chair and the secretary first and then choose the 3 extra people to be on the subcommittee. Let's look at it this way first. Let's say that the first operation is to choose the 5 people. And how many ways can I do that? Well, I'm choosing just any 5 people from the 10 people, and initially it's just a group of people. Nobody is distinguished above anybody else, so it is, I always write this the wrong way, 10 choose 5, which, I will let you calculate this yourself, but the number here happens to be using the power of my brain is 252. Okay, now operation 2 here is then to choose the officers from the 5 people. And how many ways to do that? Well, we're choosing 2 officers, and they are 2 distinct officers. There's the chair and the secretary. They have different duties. So the order in which I choose the 2 people matters. So this is a permutation of 2 people out of the 5, and this is equal to, this is something that you can compute actually fairly easily, but the number here is 20. So the total number of ways is n1 times n2, which is 252 times 20, and that works out to, again, doing math in my brain. Okay, that works out to 5040. I'm actually using a calculator, not doing this in my head, so don't worry. Okay, great. So that's one possible way. The other way is to imagine that the first thing we do is we choose the officers. And so this is choosing 2 people out of 10 people, but in choosing 2 people out of 10 people, we care about the order that we choose them because, again, the officers have different duties. How many different ways can I do this? The answer here is 90. And then the second operation would be to choose the rest of the subcommittee members, which would be 3 people. But how many people are there remaining to choose from? I've already chosen 2 people as the officers, so there are only 8 other people in the committee from the 8 people who are left for to fill out the committee. Again, these 3 people are just any 3 people, so the order that we choose them doesn't matter. So this is 8 choose 3, and that turns out to be 56. And so the total number is n1 times n2, which is 90 times 56. And math says that this should be consistent, and I encourage you to check that 90 times 56 is indeed equal to 5040. So thank gosh, that this is right. Great. Now let's look at some examples of using the addition rule, and specifically the addition rule with disjoint sets, which means that if we can break up a counting problem into a bunch of disjoint sets, then we can count each of the disjoint sets and then just add things together. So, for example, let's look at batteries. What about batteries? Well, I still have some devices that are powered by AA batteries, and for a while I didn't realize that you could just throw those out. It's fine to throw them out now. So let's pretend that they are rechargeable batteries, and those you can't just throw out, but I don't want to throw those out anyways. So let's say I've got 10 batteries, and unbeknownst to me, seven of them are dead, so that means they need to be recharged, and the other 3 are good. Now, for my Wiimote, I actually maybe still play with my Wii. Actually, I don't. I just use it to stream Netflix. So I need 2 good batteries. I pull out 3 batteries at random of the 10. So how many ways can I pull out at least 2 good batteries? Okay, well, let's check this out. So there are 2 possibilities. At least 2 good batteries. I could either pull out 2 good batteries, or I could pull out 3 good batteries. Now, if I'm pulling out 2 good batteries, that means that I must be pulling out 1 bad and 2 good. So the 1 bad battery, I'm choosing 1 bad battery out of the 7. The 2 good batteries, there are 3 good batteries, so I'm choosing 2 good batteries out of the 3. Now, so the total number of ways of me choosing 2 good batteries is 7 choose 1 times 3 choose 2, and do the workout, but this is 7 times 3, and this is equal to 21. So there are 21 ways that I could have pulled out 1 bad and 2 good batteries. If I pull out all 3 of the good batteries, well, there are only 3 good batteries. That must mean I pulled out no bad batteries. There's only one way that I could possibly pull out all 3 of the good batteries. In general, n choose n is equal to 1. Okay. So this means that the total number of ways is the number of ways that I could have 2 good plus the number of ways that I could have 3 good, because these are completely disjoint sets. It's 21 plus 1, which is 22. Let's compare this to the number of ways that I can just pull out any 3 batteries, ignoring whether they're good. And this is going to be what we're doing when we get into probability. There are 10 choose 3 equal to 120 ways for me to just pull out any 3 batteries. So this means that my chances of pulling out at least 2 good batteries are pretty bad compared to the number of ways that I could pull out any 3 batteries, because I can only pull out 22. There are only 22 ways that I can pull out at least 2 good batteries, whereas pulling out 3 batteries from the 10, there are 120 ways of doing that.